Welcome back. In our last video, we talked about doing the basics of calculus, but we used more geometric means to analyze the slopes and the areas under different types of lines and curves. So today we're going to actually talk about what really happens if we want to take the slope, find the slope of any given equation. So that's what we're going to start into today. Okay? So let's imagine we have a curve. And this is going to be a parabola. So let's just say that the equation is y equals x squared. So let's draw that on the board. In this y equals x squared, let's say we want to find the slope right at x equals 1. Okay. Now, if you think about it, how do we find slope? Well, if I want to find the slope precisely at that point, the slope of it is equivalent to the slope of a tangent line, that is a line that touches the graph without crossing it. Okay, so it's a line that touches the graph. You have to draw it just so that it doesn't. So for example, this is not a tangent line because instead of touching the graph, it crosses the graph, and so that's not a tangent line. So a tangent line barely touches the graph. And it is equivalent, the slope of the line at that point is equivalent to the slope of the graph at that point. Okay, so the problem though is finding out what is the slope of this line. So it's easy enough to draw, but what is it exactly? Okay. So usually, anytime that I'm trying to figure out something, usually one of the things that I start out with is figuring out how do I estimate it. Let's say that I want to just give up knowing it exactly. How would I estimate something like this? Well, the thing to realize is that it takes 2 points to make a line. And so we can estimate this slope by finding 2 points that are close to each other and calculating the slope. So for instance, instead of finding the slope of this line that we drew, we could calculate the slope between 2 individual points on the graph. So if I have this point and I want to know the slope right there, well, I could estimate it by saying, well, let's just start at the origin and then go through that point and find the slope between those 2 points. That won't give us an exact answer, but it'll give us an approximate answer. And we can calculate this because we can plot in these points, because at x equals 1, we know what y is because we have an equation for y. So if x equals 1, then y equals 1. So the point is 1, 1. If x equals 0, y equals x squared, so y is also going to be 0. So the point is 0, 0. So remember, we have a formula that if we know 2 points, we can determine slope. Okay? And the formula, which you should burn in your brain, is y1 minus y0 over x1 minus x0. Okay? And so you can actually choose either one of these points for your 1 and your 0. We'll take this as our point 0, and this is our point 1. Okay? So the way we calculate this, y1, it's going to be that one. So 1 minus y0, that's 0, over, again, we're going to have a 1 minus 0. It's equal to 1 over 1, which is 1. So the slope between these two lines, or these 2 points, is 1. Now, that's an estimate, and it's kind of I would say it's a bad estimate. But nonetheless, it's a starting place. That's the thing about math, is you got to get started. And once you get started, you can then get closer and closer and closer, revise until you get the answer that you're looking for. So I use that just to demonstrate simply the point that we can have 2 points and we can draw a line and use that as an estimate for the slope at the point. So the question is, how do we get this estimate to be closer to the true value? Answer, we move the points closer to each other. Okay, so let's say instead of x equals 0 and y equals 0, let's say that we pick 2 points that were closer together. Okay, so let's pick x equals 1.1, right? So we've got a point that's pretty close to x equals 1. Okay, so we have to plug it in. If x equals 1.1, so that's going to be, instead of here, we're going to do one that's slightly after it on the graph, about here. And so you can see that these points are so close that a line that goes through those 2 points is almost perfectly tangent to the graph. Okay, so x equals 1.1, y equals 1.1 squared. That's going to be 1.21. So now we use this formula again to figure out what the slope is between those 2 points. Okay, so y1, and we'll just pick this one as P1, this one as P0. So y1 will be 1.21, and y0 is 1. x1 is 1.1, and x0 is 1. So that's going to give us 0.21 over 0.1. And if we divide that out, that gives us a slope of 2.1. Again, this is an estimate for the slope, but it's a lot closer to the estimate because the points are a lot closer together. Okay? We can get even closer still, because we can, instead of finding a point that's 0.1 away, we can find a point where the x value is 0.01 away. So there, we're getting even closer. So if x is 1.01, we plug 1.01 into our formula to find y. And so 1.01 squared is 1.0201. Okay. So then we go into this formula again to find the slope between these points. And the slope is 1.0201 minus 1 over 1.01 minus 1, 0.0201 over 0.01. That'll give us 2.01. Okay, so this slope is even closer to the true value because we picked an x value that's even closer to our other x value. And we can go on this forever. We can make, we can choose 1.01 and get a value that's super, super close to the actual slope at that point. Let's consider what we would do if we wanted a general solution to this. And by a general solution, here we picked out two particular points, and then we calculated everything and came up with a value. Okay, but what if we wanted a formula that said for any place on this graph, I want to know the formula. Okay, so what would we do for that? The way to think about that is we want to have a formula that's entirely in terms of x that will give us a given slope of 2 points that are close to each other. So let's say that we want a formula. So this is going to be the formula for the slope. Okay. So if we have the equation y equals x squared, okay, so what we want to know is given any value x and any value x plus 0.1, right? Because this will be our close by point. Okay, so we'll have two points, some x on the graph, and x plus 0.1, some x a little bit further. What is the slope between the points generated here? Okay, so in this formula, what are we going to have? Well, on the bottom, our x1 will be x plus 0.1. Our x0 will be x. And then on top, our y1 will be this squared, because it's y equals x squared. So we'll have x plus 0.1 squared minus y0, which will be this squared. So if we solve this, and let's do that, or simplify, I should say, on the bottom, notice we have x plus 0.1 minus x, right? So the x's cancel out, and that gives us 0.1 on the bottom. On the top, we'll have x squared plus 0.2x plus 0.01 minus x squared. Now what happens here? We've got an x squared and a minus x squared. So those two cancel out. And we're left with this. So if we divide this by 0.01, that will give us 2x plus 0.1. So on any point in this graph, if I want to know the slope between this point and the point just a tiny bit after it, I can use this formula to tell me. All right, so let's look at what happens at x equals 2. Well, at x equals 2, according to this formula, the slope between x equals 2 and x equals 2.1, because I'm using this, will be 2x plus 0.1. So that'll be 4.1. So that's the slope between the points represented by those x values. And so I can do that for any place on the graph. If I want to say, well, what's the slope at, what's the approximate slope at x equals 5? Well, we're approximating the slope by taking x equals 5 and looking at the point where x equals 5 0.1. And this formula we calculated for any generic x. And so we can say that the slope is 2 times our x value plus 0.1. That's equal to 10.1. Okay, so we can recalculate this formula for however close we want the 2 points to be. So for example, instead of looking between x and x plus 0.1, we can find 2 closer values. So we'll make a formula that will look at the slope between the points, x, any given x, and x plus 0.01. Right? So that'll bring them even closer together. So what is it? Well, on the bottom, our x1 is x plus 0.01, and our x0 is x. Now on the top, our y1 is going to be x plus 0.01 squared. Okay, because we'll feed this into that formula. So, and then minus, if we just feed x into that formula, we get x squared. Okay, so when we unwrap this, it'll give us x squared plus 0.02x plus 0.00, let's see here, how many zeros? 0, 1. Okay, minus x squared all over, and these x's subtract each other out, so all over 0.01. And so these two x squareds cancel each other out. And when you divide 0.01 into this, it moves the decimal point over 2 places. So that gives us 2x plus 0.01. So the slope between, so now instead of these points being a little close, they are super duper close. You can't even see how close they are. They're so close to each other. All right, so this gives us a formula that says that if I have at x equals 2, what's our approximate slope? Well, our slope is approximated by this formula. And so if x equals 2, then the slope is about 2x plus 0.01, and that's about 4.01. Let's look and see if we can get, here we keep on changing this value and getting a different formula here. Okay, let's, instead of setting this to be a specific number, let's set it, this is why we use letters in math, is because we want to do something that's more general. So instead of saying x plus a specific number, we will use h as our number. And then later we can decide how close we want those points to be. Okay, so we'll say x is our starting value, and x plus whatever h is, which we can decide later, is going to be how far apart the points are. Okay, so you might say, why do we use h? Why not? It's a letter that's available. So going back to this formula, so on the bottom, our x1 is going to be x plus h minus x. Okay, so our x1 is x plus h, and our x0 is just x. On the top, if I put x plus h in for x in this formula, I'll get x plus h squared. And if I put x into this formula, I'll just get x squared. So when you unwrap that, you'll get x squared plus 2hx plus h squared minus x squared all over h. Okay? So now we can simplify this formula. These x squareds will cancel each other out. And then the h we can divide out, and that'll give us 2x plus h. So for any point on this curve, the distance between the slope can be given by this formula, where h is however far apart we want those 2 points to be. So if I want to say, what is the slope at x equals 3, I want to know what happens when they are 0.00001 apart. Okay, well, this formula tells us that the slope between 3 and 3.01 is going to be 2 times our x value plus our h value. That's going to be 6.001. Okay, so this is going to be the slope between those 2 points. And we can get those points as close together as we want. We can say, what's the slope between x equals 3 and another point that's even closer, right? And so this formula will tell us how to do that. Okay, so what does this formula say? It's going to be 2 times x plus h. And so we will have 2 times 3 plus this long number, which will give us 6.0, and I'm not going to count how many of these I have. So you see our slope is converging on a number. What number is it converging on? It's converging on 6. Okay, because as we make h smaller and smaller, this gets closer and closer to 6. But how do we know exactly what it is? Okay, and so this is a trick that was very controversial for a while, and I'm not going to prove to you why it works here. That's actually going to be later on. We're going to deal with these types of numbers explicitly, but let's just say that h was so small, we moved h to be so small, this distance between the points. We're going to make that so small so it is effectively 0. So there's no distance between the 2 points. Well, what happens to my formula? Well, if my h is 0, the h drops off. And so therefore, my slope at any point on the graph is 2x. So my exact slope at x equals 4, my slope will be equal to 2 times my x value, and it's 8. Okay, so that's the exact value. And you might say, well, if h is 0, how could we have divided by h? Okay, and as I said, we'll get into this more rigorously later on in the course. But for now, you can think of h as being a number that is so close to 0 that we can effectively reduce it to 0 when we want to, but it is sufficiently far away from 0 that we can divide by it. And as I said, we'll get into the precise nature of h much later on in the course. But for now, it's good just to know that it's close enough to 0 that it can act like 0 when we need it to, and it's far enough away from 0 that we can divide and simplify by it. The slope for y equals x squared at any given point is given by 2x. And the way that we write that is we say y prime equals 2x. And this is the derivative. So if this is our original equation, this is our derivative. Okay, and so we mark the derivative with this little quote mark. It's called a prime. And y prime equals 2x, or the derivative of y equals x squared is 2x. So that means that on this graph, at any given x value, we can find the slope of this graph using this formula. Okay, so we can do this same process for any equation that we want. We don't need the graph. The graph was just there to help us think about things. All we need is the equation, and we can generate an equation for the derivative. So let's look at another equation. Let's say y equals x cubed. Okay, so let's take that equation. Y equals x cubed, and we want to know a formula for the slope at any given point. Okay, so what's our basic procedure? Well, remember that the formula for the slope, and never forget this, this is the formula for the slope. If we have 2 points, then this is how you find the slope. Well, I'm going to make a more general statement than that. So notice that the way that we have this constructed, y is a function of x. Okay, so we can say, instead of y equals x cubed, we can say f of x equals x cubed. Okay, so we can then, instead of having y values in here, we can say this is going to be f of x1 minus f of x0. Okay, and these are equivalent to having the y values in there. But as you'll see, that it will get some more benefit by putting these x's in there directly. Okay, so f of x1 minus f of x0. Okay, and so remember that the process that we're doing is we're actually finding 2 points that are super close together. Okay, and we're using h to represent their distance from each other. Okay, so the first one, so x0 is just going to be whatever x value that we're looking at. And then x1 is going to be that same x value bumped up by a very small amount that we'll call h. Okay, so we have x0 is x and x1 is bumped up by h. So now we'll replace these in our formula. Okay, so instead of f of x0, we'll just do f of x, and instead of x0, we'll just have x. And instead of x1, we'll have f of x plus h. And instead of x1 here, we'll have x plus h. Okay. So now this tells me what I'm going to need to do to work the problem. Okay, I'm going to have to run x through our function. I'm going to have to run x plus h through our function and divide by this. But look, we can simplify this. X plus h minus x is just h. So this is the general formula for finding the derivative. Okay, so if I have a function of x and I want to know the derivative, and we can tell this is a derivative by that little prime symbol. So I want to find f prime of x. I want to find the derivative of my f of x. Well, I do it by using this formula. Okay, so let's run through using this formula with x cubed. Okay, so f of x plus h, well, f of x is x cubed. And so the way that we do functions is we'll replace x plus h, we'll replace x with x plus h in the formula. So this will give us x plus h cubed minus f of x. Well, if I put in x for x, I just get x cubed all over h. Now to actually work the problem, I have to expand it out. So x plus h cubed, what's that? Well, that's kind of hard. So we'll start by just separating it out into x plus h times x plus h squared. And that will give us x plus h times x squared plus 2hx plus h squared minus x cubed all over h. Okay, so now if we multiply this through, we'll get x cubed plus 2hx squared plus x plus h squared x plus hx squared plus 2h squared x plus h cubed minus x cubed all over h. Okay, so some of these combine. So hx squared, I also have another, so these two combine and these two combine. And then these two subtract out. And that leaves us with, let me erase this. That leaves us with 3hx squared plus 3h squared x plus h cubed all over h. But we can simplify it further. We can divide h through here. So we'll do that. We'll divide out h, and that will give us a final formula of 3x squared plus 3hx plus h squared. And so this is the formula for the slope between any 2 points that are h distance apart. But remember what we do next. Next, we say, well, what if the two x values are so close together as to be practically, the distance would be practically 0? Well, if the distance is practically 0, if h goes to 0, then h squared is also 0, and h times x is also 0. And so that leaves us with 3x squared as the final derivative. So f prime x, if f of x is x cubed, then f prime x is 3x squared. Okay? So note that all of this just uses what we already know from algebra. We knew this formula for the slope. So let me remind you what our process was. we took the formula for the slope, y1 minus y0 over x1 minus x0. We took the formula for the slope and we converted it into a general procedure for finding slopes between points that are very close together. And we use this h to represent the distance between those 2 points, at least the x distance between those 2 points. And then we use this formula, which you should memorize. This formula is basically just a restatement of the slope formula. Okay, so you should memorize this, but realize that where did it come from? It came from, this is literally the slope between 2 points that are h apart. Okay, and so then we can take this, and any f of x that we want, we can plug in to this formula and find out what the derivative is. Now you'll find that these can get very unwieldy very quickly, because notice when we had x plus h cubed, that took us a lot of paper to figure out all of the different components of that. We'll learn very quick ways to solve these in the next video. But for now, I just wanted to concentrate on the general rule and the general procedure for coming up with derivatives. And you can use this to find the derivative of any function of x. Okay. Okay, so let's do one more just to hit home the point. So let's say we have, we have the equation y equals 2x squared minus 5x plus 3. Okay, so this is a little bit more complicated of an equation, but it's the same idea. Now notice that the equation is written as a function of x. So instead of saying y, we can say f of x. And now we can use the same formula to find the derivative of that function. So if f of x is this, then f prime of x is going to be, we're going to put x plus h in for x in this whole thing. So it's going to be 2 times x plus h squared minus 5 times x plus h plus 3 minus, and now we're just putting in x for x, so we're just going to repeat this formula, minus 2x squared minus 5x plus 3. I put this in parentheses because we're subtracting this whole shebang, not just one piece of it. So now, and then all of this goes over h. Okay, so notice the x plus h's replaced the x in every case. So it doesn't matter how many times x occurs, each time we have an x, it'll be replaced with x plus h. And then over here, we just restate f of x because we're just substituting in x for x, which means it'll give us exactly this formula back. So I'm going to erase this so we have more room on the board. And we're just going to solve this. So f prime of x is going to be equal to 2 times x plus h squared. So that's x squared plus 2hx plus h squared minus 5, we can go ahead and distribute this, minus 5x minus 5h plus 3, and we'll distribute this minus, so minus 2x squared plus 5x minus 3 all over h. Okay, so so this 5x and this 5x subtract each other out. And this 3 and this 3 subtract each other out. Okay, so now let's distribute this 2. So f prime x equals 2x squared plus 4hx plus 2h squared minus 5h minus 2x squared all over h. Okay, so now we have these 2x squareds cancel each other out. And if we divide this whole thing by h, the final answer is f prime x, I guess this isn't quite the final answer, was 4x plus 2h minus 5. Okay, so, but then what do we say? So what does h represent? H represents the distance between the two x points we're finding the slope between. And in this case, since when we're trying to find the exact slope at a single point, the distance between the 2 points is effectively 0. So we will then, at this point, say, well, what happens when h equals 0? Well, when h equals 0, this simplifies because 2 times 0 is 0. So that just becomes 4x plus 5. So for this equation, f of x equals 2x squared minus 5x plus 3. The derivative, oh, sorry, that's minus 5. The derivative is 4x minus 5. So that's the basics of how you do derivatives the long way. As I said, we're going to find shortcuts. We'll find, next week we'll find a super simple way to do derivatives of any polynomial you want, and you'll be able to do it in your head in seconds. This way, the reason why we start with this way is so you understand what it is that the derivative is doing and how rules about derivatives are proven and how we understand the derivative as a slope. It actually came straight from the slope formula. So anyway, this is you can use the formula for the derivative to find any derivative that you want. So I'll see you next time.